Hi, my name is Tyler DePrano, and I'm going to be doing an immunology video on T cell development. So, this is going to be basically describing how T cells develop, and the first thing we need to know is where they are going to develop. So, T cells are first going to start off as hematopoietic stem cells, and this will be in the bone marrow where all the stem cells are normally going to be located. So, the stem cells are in the bone marrow, and from here they will differentiate into stem cell precursors. So they will, from there as those precursors, they will migrate into the thymic cortex in the thymus, and here those precursors will become T cell precursors. Alright, so next location from the thymus, the T cells are going to develop a lot, and they are eventually going to take the path of a T cell. And by taking the path of a T cell, what we mean is that they will choose to become T cells, and they will choose to develop the correct receptor that they need. And once they have these receptors, they will undergo selection, and from there they will be matured, and once they are matured they will be allowed to go into the bloodstream or the lymph, and they will migrate to any periphery tissue or wherever these T cells will end up residing. So let's just get an overall look at everything. So you can see that they start off as hematopoietic stem cells, and I don't have every single step here, but these will eventually develop in the bone marrow to a stem cell precursor, and then they will go to the thymus where they'll become the T cell precursor. So we've got the hematopoietic stem cell up here. The T cell precursor will form in the thymus, and double negative 1 to 4, so this is just stages of development as the precursor decides to become a T cell. So it's going to decide to make certain changes to its receptors, and it will be negative for certain receptors. So what I mean by negative is that it's not going to respond. So once it does develop the correct receptors, those will be the CD8 and the CD4 co-receptors, and that, once it develops those CD8 and CD4 co-receptors, it's going to be a double positive T cell. Okay, now I believe it's some number like 95% of cells that don't end up developing properly, and they will go and die because they just aren't going to be recognized by anything, and they aren't going to undergo any kind of maturation or anything, and they will simply die. Now the double negatives can also go and form NK T cells or T regulatory cells, and a few other cell lines that they could go through. So back to the CD8 and CD4 T cells are double positives. From here, our T cells are going to be grouped into CD8s and CD4 T cells, and they will be positively selected for. This is still in the thymus, by the way, so we're still in the thymus as all this is going on. And after positive selection, if they are positively selected, CD8 and CD4 T cells will be negatively selected for, testing to see if they can recognize self-antigen, and then they will be allowed to circulate. So once they can circulate, they'll go and migrate to the tissue that they will end up residing in, so periphery tissue. Alright, so let's go and take a quick look at positive selection and see exactly what's happening in these two steps with this T cell development as far as positive selection goes. again, this is basically just what I went over. This is just in like a text form, so T cells are going to develop to the double negative 4 stage, develop to double positive stage, positively selected for, negative selected for, and immigrate to periphery tissue. So positive selection. So only T cells that can recognize self-MHC are going to be able to pass this step. So what happens is, if you come over here and look at the image, the T cell is in blue, and see that co-receptor, CD8 and CD4, that's what those are. So they're binding to self-MHC, and if they can bind, if they don't bind too strongly, and they bind just enough, they will go and be single positive. So it's not binding both. It's only binding CD8 or it's only binding CD4. So these T cells are going to only develop CD8 or CD4. And this will come down to just based on which one they bind better. And when they are binding here, you have to understand that it's just checking to see if they bind too strongly, not at all, and if they do bind too strongly, they're going to be destroyed by apoptosis. If they don't bind at all, let me just come back here. If they don't bind at all, they end up being the death by neglect. But if they do bind too strongly to this self-MHC, they're going to something's going to induce apoptosis within these T cells and destroy them, because you don't want them to stay stuck to NMHC, because that just wouldn't be good. So you don't want them to have a high affinity for the self-MHC that they're being exposed to. And when I say self-MHC, I don't mean self-antigen, I mean self-MHC, the molecule MHC. So it's testing for just the things that bind the self-MHC correctly and just right. And this will end up with the self-MHC restriction of T cells. Okay? So let's look at negative selection now, because that's what's going to come after positive selection. So in negative selection, T cells are going to be exposed to self-antigen. And antigen is just going to be a protein from around the body, any protein, it's random. So there's this protein AIR. It stands for an autoimmune regulator, so AI, autoimmune regulator, is RE. And AIR collects self-antigen from various organs around the body and then presents them to these T cells in what we call negative selection. So here you can see the T cell is reacting to the self-antigen, that's self-AG in the image, and when it reacts, it is deleted. Now, medullary thymic epithelial cells, these are going to be containing the self-antigen from AIR. So AIR is undergoing apoptosis, and what's left over is that medullary thymic epithelial cell, and it still has the self-antigen there. And what happens is dendritic cells in the thymus can consume this. So once AIR is destroyed, the self-antigen is going to be consumed by a dendritic cell. And the dendritic cell can also present that self-antigen to autoreactive T cells and have them deleted. Okay? So let's say, what happens if AIR fails? What happens if there is no AIR? This is just how they actually found out what this protein does in the body. This is the experiment they did. What happens if there isn't an AIR protein in the body? Well, if there's no AIR protein, then you're going to have autoreactive T cells just go into the periphery. So you'll have T cells coming and reacting to the peptides that naturally occur in your body, and you don't want that. So air is very important. It is a key step in negative selection, and it's very important as well because it helps out the dendritic cells collect peptides from around the body. Thank you, and that has been T-cell development.